learn ADT of the array, then operation, array applications for the searching, and then after that we going to discuss about sequential search. Then we are going to talk about variations, Zenitial search, probability search, ordered list search. Then we will talk about binary search. Then we are going to talk about comparison of searching method. Then sorting technology, we will terminology talk, internal, external, stable, in place sorting. Then comparison based sorting and non-comparison based sorting, comparison based and sorting methods. So these are the things we are going to agenda for this video. So let's talk about what is the ADT of an array and operations. So ADT of an array, first of all, you see there, if you see here clearly, then it's a display. You see, so this by this append, by this index, by this insert, delete, by this search, get, index, max. Now here you have this one is arrays, and this is the arrays, and these are the remainders. So then array is the basic abstract data type that hold an ordered collection. So it is ordered collection, right? It is the ordered collection for the item accessible by the integer index. These items can be anything from primitive data types such as integer to more complex type like instance of the classes. Simply know what is the data structure with the example ADT in the data structure. So abstract data type is the data type where only behavior is defined but implementation. Opposite to ADT is concrete data type where content implementation of abstract data type, example array, list, map, cookie, set, stack, table, tree, and vector of the ADT. Let's talk about an example. So you are going to have an unsorted array and you need to sort them. So for example, this is the arrays. You need to sort them by the medium. Where is 3? 3 is here. There are the various operations you are going to follow for the searching of the arrays application. So first of all, insertion at end. So insert at the end. First of all, you need to insert at the end, and in the unsorted array, in the insertion operation is faster as compared to the sorted array because we don't have to care about the position at which element is placed. Now insert, here you can see insert operation in the unsorted array. So this is unsorted array, and now make it sorted array. One more example, like a insert at any position. So insert operation in an array at any position can be performed by shifting element to the right side, which are the right side of the required position, like inserting an element at a specific position in an array. So here you have the sequential manner for the elements, and now you are trying to insert with the position. Now talk about delete operation. So in the delete operation, in the element as a deleted is the searching using linear search, and the delete operation is performed followed by shifting the element. So delete operation in the unsorted array, first of all 3 5 1 4 3 2 6. So here you want to delete 3 5 1 4 2 6. You deleted this by this shifting. By this shifting you delete this one. Now talk about sequential or linear search. So linear search is sorting algorithm which go through in the linear form. So in the computer science, linear search is the sequential search, is the method for the finding an element within a list. So it's a sequentially checked the element, a list of the list until the match is found, whole list has been searched. So what is going to be in the linear search? For example, you have like these elements. So first is go to here, then here. So in the linear way, in the sequential check of the each element until the last element until the match is found. Here you can see an example of the linear search. Here I have 10, 50, 30, 70, 80, 60, 20, 90, 40. Right. So first what my element? First go to 0, then 1, 20 find, no not found, then 30 not found, 70 not found, 80 not found, say 60 not found, 20 found. So my element is got here. So it's a linear search. Let's talk about sentinel search. Sentinel search is a basically a sentinel is a linear search, as the name suggests, a type of the linear search where the number of the comparison is reduced as compared to the traditional linear search. So it's meaning what you have the linear search, but number of the operation is reduced. For example, if I say guess which number I have, you say that you have 4, and in the reality I have 5, so then you say 5, so 5 you got it. So it means number of so in the type of the linear search, where the number of the comparison reduced at compared to traditional linear search. What was the traditional linear search? Traditional linear search was like a every step by step whenever you don't get that number element. Now talk about the probability search in the data structure. So probability search going to be, it's a binary search also known as a half interval search, logarithmic search, and binary chop. It search algorithm in position target value within the sorted area. So binary search compare the target value in the middle element of the array. For example, I have selected 8 in my mind, and I say to you guess the which number I have. So you say it's like a 8, then you say 10, then so you have probability search is like that. So what is ordered list search in the data structure? So the structure of an ordered list is a collection of the item where each item hold the relative position that is based upon some underlying characteristic of the item. The ordering is typically either ascending and descending, and B assume that the list item have the meaningful comparison operation that is already defined. Binary search in the data structure. So what is binary search in the data? Binary search work on the sorted array. Binary search begin by the comparing an element in the middle of the array with the target value. If the target value matches the element, its a position in the array is written. So what was the binary search? Binary search is a like a begin on the comparing an element. For example, you can see here binary search is like this example is, so it's work on the comparison. When we all data that need to be sorted cannot be placed in the memory, at that time the sorted is called external sorting. External sorting is the used to the massive amount of the data, merge sort, and it's a variation typically used to external sorting. Some external sortage like a hard disk cd are used to external sorting. So what is the difference between internal and external sorting? So difference between internal and external sorting is, internal sorting is used when the input data can be adjusted in the main memory all at once. External sorting is used when the input data cannot be adjusted in the main memory at once. The data to be sorted should be small enough to fit the main memory. What is the comparison based sorting and what is the comparison sort? So comparison sort is the sorting algorithm that only read the list element through a single abstract comparison operation when often less than the equal operator of the 3b comparison. It should be occur first in the final sorted list. You can also understand comparison based sorting by this diagram. So if you see they look like this, they are the comparison based sorting, lower bound and upper bound, and comparison based. Now talk about what is the bubble sort in the sorting algorithm. So bubble sort is sometimes referred to as a sinking sort in the simple sorting algorithm that repeatedly step through the input list element by element, comparing the element with the one after it, swapping the value it's needed. Worst complexity, average complexity, then best complexity. Here you have the space complexity. So if you see this diagram, this is the example of the bubble sort. What is the insertion sort in the sorting algorithm? So insertion sort is a simple sorting algorithm that builds the final sorted array, and one item is the time by time comparison. It's much less efficient on a large list than more advanced algorithms such as quick sort and heap sort and merge sort. This is the example of the insertion sort, and here you can see the example of the insertion sort execution.